what I can do, and I can actually do quite easily, is I can check if all of the unique letters in my word are also present in my hand. And by doing that, I can at least evaluate whether or not I can use the tiles in my hand to potentially spell the word. And what you might not know is that the keys of a dictionary actually support set-like behaviors. And so I can do something like this. I can say, and I'll print this out first, print word counts, and I'll use the dot keys here, just so you can see what this looks like. I can actually test if, and I'll print my word. I can actually test whether or not each letter in my word counts dictionary is also available, at least in my tile counts. And this less than equal sign is doing a lot of heavy lifting for us. This is our subset operator when working with Python sets. So if you're not familiar with Python set, this is a very easy way of asking, are all the things on my left-hand side, are they also in the right-hand side? Is my left-hand side a subset of my right-hand side? And that's exactly what we're asking this code here. Now, this is telling me that yes, it is a subset for the word hello. Let's switch this back to our original example where we saw the word Python and the word think, and we'll see that we now have two truths, one true for Python and one true for think. So potentially, this is getting us on the right track. There's going to be one more caveat here that I can at least see right away. But let's at least add this as a first pass filter. So with our example where we have the tiles in our hand, P-Y-T-H-N-O, I, and K, we have two candidates, one's Python and one is think. Now, right away, I can absolutely spell both of these words, but you can think back to the case of hello. Well, when I have all of the tiles for hello in my hand, this works. When I have one L short, we see that we also pass this specific test, or pass this if statement here. But you're probably thinking, well, if I only have H-E-L-O in my hand, of course I can't spell H-E-L-L-O. I need at least two L's. And so that's probably going to be our second filter that we check here. I'm going to need to check to see if we have enough letters in our hand to spell the word that we have matched on our keys for. And so I might do something like this. I might iterate over each letter. And so we would say for each letter and its count in my word counts dot items. So iterating over my word counts, I would need to check if the same matching letter in my hand, and we call that tile counts, is at least the same size as the current count for the letters in my word. So this is literally asking, do I have enough of this tile to match the same count as the tile in my word? And now if I just work like this, I'm stuck in a little bit of a deep state here, but we can always unwind this for loop a little bit. I just want to see if this is working the way I think it should. And so as a reminder, we have the words H-E-L-O in our hand. And we'll print out each of these letters. So L, C here, and L, C here. And just for my own sanity, right, this will mean we have enough letters, and whenever we see a false, this means we don't have enough letters. So what this code is, or output is telling me right now is I have enough letters for the H, I have enough letters for the first E. I do not have enough L's in my input though. And so effectively, what I would want to do here is check if all of these Boolean values are going to be true. And we can use that as a hint. Whenever you need all of something in Python, we can of course use the all operator. And I can just go ahead and say this. Throw this into a single expression, like so. And let's see if all of our tile counts, that looks good. And running this, we get no output. If we add our second L back, we see that we do get an output of hello. Let's test this again against our Python and think example. And it looks like we have something of a working prototype here. Now I'll move these words down here since they're not doing me too much service up at the top. And we'll probably go ahead and refactor just a little bit of this code. Now that I have some just basic code out of the way, well, how can I make this a little bit more reusable? Because we're going to think that the letters in my hand on turn 1 are not going to be the same letters in my hand on turn 2. And so I might take this logic and throw it into a function and call this find candidates or something of that nature. So here we have some letters, and then we have a enumeration or a set, a list, some container, right, of all the possible words we can match against. Then from here, we can take this logic to build up our data structure. So we have our tile counts here, and you can see I'm actually reusing the same piece of logic. I would say that this isn't just incidental, right, or coincidental repetition that I have here. This is intentional. So maybe I'll refactor this to a function, maybe counts or letter counts here. And then we would provide a word or some text. And then we would just use this pattern here. And then I'll return a dictionary. So here we would have tile counts is equal to letter counts of the letters. And then the word counts is equal to the letter counts of the current word that we're looking at. And then let's go ahead. We'll need to, of course, call this function. So find candidates. And of course, we'll move this to the top, or we'll move these pieces down here, just so we can work with them a little bit easier. And our find candidates, I said that it takes some letters, and then it takes a list of words here. So we have our tiles, and we have words. And it does, in fact, print out each of our candidates here that we have found. Let's try this, of course, again with our hello problem, just to see if this passes. All right, so we're looking pretty good here. We can find hello, we can find Python, we can find think. But the next thing that we'll want to do, well, I'm going to say this, it's not very convenient to work with a function that prints. We're going to want to return something. But since we want to return, well, maybe 0 things, maybe 1 thing, maybe even more, the easiest thing I could do is to yield out, right, this current word, since it matches my criteria. So now I can print my find candidates function. I'll separate these out on a new line basis, and we can work with each of these things. If I wanted to have a list of all my candidates, I could, of course, right, unpack this into a list, and all of a sudden I have a single collection with all of my possible words that I could create using them. Now from here, if I had a move to make, well, I could use that move and I could figure out the best word. I could take a random word. I could say, well, I'm going to play either Python or think, you know, just take a random 50-50 guess. But I do know that we have some way of scoring this. Thanks for watching. If you enjoyed this video, give it a like, hit subscribe, and check out the recommended video on the screen. See you in the next one.